So, Dr. M.Y.S. Prasad, Director of Satish Dhawan Space Centre, a distinguished engineer and very recently the holder of the Vikram Sarabhai Memorial Award 2014-15. Congratulations.
Thank you very much.
You have a very long connection with ISRO. When did it start?
See, I passed out of the college in 1974, almost 74 November. Then I joined an engineering college as a lecturer for the electronics department. And within a few months, I got an interview call in the ISRO, and I joined the Vikram Sarabhai Space Centre in Trivandrum in May 1975. So it's almost, for this May, it will be 40 years.
Right.
So it is usually for the Western executives,
Right.
sticking 40 years to a company is generally rare. and in India, we have a good custom of good loyalty to the work and the employer, and especially if it is especially government job.
Right. Yes.
So it's 40 years going to be. I'm going to complete 40 years in this week.
You have worked in many areas within ISRO, but right now you're the director here at Sriharikota. What kind of facilities are here? What does ISRO use Sriharikota for?
See, the Sriharikota island, this is an island cut off with the backwaters as well as a lake on the western side, Pulicat Lake. This island was very sparsely populated, very few people. So in the early, late 60s, it was decided by Professor Vikram Sarabhai that this is the place where there is going to be launch center for ISRO. And over years it had developed. I should say over almost 4.5 decades, it had developed into what it is today. Today, we have large entities. First of all, this center has got about 2,000 regular employees, and another 2,500 people work on contract basis.
See.
So about 4,500 people work here. And we have an annual budget of roughly 550 crore rupees in India, which is equal to something like $100 million.
Right.
Okay, $100 million US dollars. Now, we have solid propellant manufacturing facility here. 2 facilities, 2 plants. Right. We manufacture solid propellant, and we manufacture both of them put together something like 700 tons of propellant per year. And then we have another entity which is dedicated for the liquid propellants and the cryogenic propellants. And there we procure and store, maintain and service them. And when we have count down the propellant loading into the launch vehicle, all these actions take place. And that entity stores something like 500 tons of propellants always here.
So 500 tons. So is that cryogenic and liquid, or what together?
Both put together. Cryogenic is a smaller quantity, but larger quantity is the earth storable propellants, because we use them in the bigger stages. Then we have another entity called solid motor performance monitoring and the environmental test facilities. That entity does all the ground tests on the small size motors to characterize the solid propellant what we manufacture, and the small scale casting. Whenever you manufacture a big rocket motor, we also manufacture a small sample to find out exactly its mechanical and ballistic properties. So all that is carried out by this entity, in addition to vibration, shock, acoustics, and the thermo vacuum tests. Some of the motors have to fire in the vacuum, so we have small thermo vacuum chambers in which we can fire a motor and get its properties. So that is another entity. And we have another big entity called Vehicle Assembly and Launch Facilities. So they prepare all the subsystems. Basically, a launch vehicle is built here. But subsystems come from different centers of ISRO. So various subsystems and the satellite all converge here for a launch. So each of them has to be prepared, to be tested, final assembly. For example, certain separation system you cannot assemble and transport. You have to assemble here. And certain wire tunnels connecting different segments have to be connected here. So that type of activity is carried out separately. So we have subsystem preparation. And for example, if we bring a cryostage, we have to do absolute measurement about the integrity of the insulation system and leak checks and various tests we have to do on each subsystem. So each subsystem we prepare. Then the solid propellant rockets are big motors, we call them. The big motors we start stacking, and the liquid propellant motors and stages which come from outside, we test and move them. So all subsystems are prepared, satellite is tested, they are all moved to the launch facility and integrated in the launch facility. Integrated by our team as well as from the teams of the other centers. So that entity is called Vehicle Assembly and Launch Facilities. And then we have another big entity called Range Operations. The range operations is to take care of all the data, computer networks, and connecting all of them. And then we have a network of 6 radars and a large number of meteorological facilities to forecast, to monitor and forecast the weather, especially during launch time. It's very critical. And we have the timing, generation, distribution all over, so that all people work on a precise time. And then communications and communications with external world like air traffic control, sea control, coast guard control. So various operations related with the launch and post-launch. Till satellite is injected into the orbit, it is the responsibility of Satish Dhawan Space Centre to track and exactly show the trajectory and also to get the orbit and then preliminary orbit and hand over to the satellite managing centers. Okay, so that is another entity. So we have the solid propellant manufacturing two plants, and liquid propellant storage and servicing, and vehicle assembly and preparations and launch facilities. We have 2 launch facilities, and then the range operations. And these are the major technical entities.
Now, for 4,000 people, for 5.5 crore, that's quite a lot to do.
550 crore.
550 crore, 100 billion US dollars.
Yes.
That's quite a lot you do here. One center.
Yes.
Now, you said you store the liquid and cryogenic fuels here, and all of the satellites and various components come from other centers. How are they transported here? Are they come here by road, or because you're on the coast by sea?
The liquid propellants, you mean, or the stages?
Yeah.
For example, for the solid propellant to cast, the rocket motor case is manufactured in some industries outside, and that is transported by road. And satellite is transported by road from Bangalore to here. And the liquid propellants, what we procure, are the liquid nitrogen or such cryo liquids. They're all transported in the containers. We have an organization called PESO, Petroleum and Explosives Safety Organization, in the country. Every operation of any explosive liquid storage in the country has to be under their license. So all our transporting vehicles, etc., are licensed by them after a thorough testing and inspection. And we have to maintain them in a periodical manner. For example, even a tank in which we store the propellant inside has to be tested once in 4 years, fully. That means we have to remove the whole propellant and test it for its integrity and show the results to them, get it approved, and then again we can do it. So we follow all these procedures.
I remember a story, I think it's just before your time, when the very first rocket launch, the Nike Apache rocket from, this is Tumba, and they had the same problem with the payload. This is a sodium container, came from France. Professor Lamont arranged that. And they had the same problem because it's an explosive device, they had difficulty getting the clearance. So I understand that. So you don't use sea transport for any of this, it's all by road?
We, so far, not in India for our own launches.
Right.
Okay. But once we had sent certain, on commercial basis, we have launched certain small rockets, sounding rockets from Norway.
Yes.
So we transported it on ships. In fact, the rocket motor transportation is not very serious.
Right.
In the sense, it does not come under the category of high explosives.
Yeah.
It is quickly combustible, but
It's
not high explosive. Whereas high explosives transportation is much more serious, and you have to follow many more regulations.
And you don't have any airports here, you've got plenty of space. Maybe sometime in the future you can have a runway here and get greater links.
We have a helipad here where 3 helicopters can land at a time.
On launch day, you are in the control center, and you've done this many times. And you know, rocket science has been around for some time, but still is not risk-free. When the countdown comes down to, let's say, T-minus 10 seconds, as the director of all of this, all the things that have to come together, what are your feelings? How do you feel at that time?
Yeah, it's a very critical time. First of all, when we reach almost T-minus 10 seconds, we are almost 50% in relaxed state, because all the actions which are supposed to be completed before that have been successfully completed. Okay. Now the question of only next few seconds. And then we also do not, every second when they are giving the countdown, I will be personally thinking about the next action, and I'll be organizing my which computer monitor to see, which line in the display to see, which number to see. So exactly, I should say, I have never felt there is time to worry about it. Okay, our worries are much before, not from T-minus 10 seconds. Our worries will be when we are loading the whole propellant into the launch vehicle. For example, we have to load in GSLV something like 220 tons of unstoreable propellant, highly toxic, and there should not be any leakage. That is the time where we feel more tense than the last few seconds.
Oh, I see, right, yes.
Okay.
Because dealing with that kind of fuel is very...
Those operations are much more critical.
And I watch you on TV, this is all transmitted live. Having a TV crew looking at everything you're doing, that must add to the pressure and tension of the day.
No, we are accustomed to blank out everything except the 2-3 monitors in front of us. Okay.
The most recent launch was the GSLV 3 with the human module, crew module. It wasn't occupied, but it was a suborbital flight. And it was the GSLV Mark III. How is that launch different from the ones that you do normally, mostly GSLVs?
Yeah, it's different from 2-3 angles. Number one is the 2 solid rocket motors, which will ignite and take it out. I mean, lift off happens. Those 2 solid motors are the biggest solid motors which we have manufactured in ISRO and in Stock Center.
Right.
each one carrying about something like 200 and odd tons, 205 tons of propellant. That is number one. So it is our own manufactured two solid motors are the first things to ignite and lift the whole vehicle up. The second thing is when the lift-off is happening, the two nozzles have to come out of the steel structure on which it is sitting. Something like about 4 meters they have to come out without hitting any portion. That means the initial thrust on both of them have to be so accurate not to create any tilt. The third thing is, at the time of takeoff, from T minus 2 seconds to T plus about 2 to 3 seconds, we pump about, for this particular launch, we pumped about 20 tons per second of water into the plumes of the two solid rocket motors to reduce the acoustics by 6 dB, 5 to 6 dB. That means to reduce the whole acoustic power by 1/4,
And that's
to 1/4.
And that's to reduce the vibration.
And that is to reduce the acoustic energy, which will excite vibrations in the launch vehicle. So this has to occur very accurately at T minus 2.4 seconds, T plus 0.2 seconds, T plus 2 seconds, and at the same time, the water should not hit the launch vehicle.
Right.
And these are the initial things when it takes off. And then the whole launch vehicle control is decided upon how these two motors work as a matched pair. If they work perfectly as matched pair, launch vehicle is success. If any of them creates a differential thrust between them, it will be very tough to control, especially during the tail-off period. That is the one part of it. The second part of it is the liquid stage. What we have is having 110 tons of propellant. So, any incident yet are very near the launch pad, like Antares or the last Proton or Soyuz. Okay, it will be, that is the type of things which will be in my mind in the last few seconds rather than what is exactly happening. Okay.
So the two solid motors are a bit like the space shuttle. They have to fire first and then the liquid engine.
No, liquid engine is ignited at something like 114 seconds in the flight.
So the whole vehicle can be launched by the solid rockets.
Yes.
Just by them.
Because the GSLV Mark III launch vehicle, experimental we made 1:1 with respect to takeoff mass. So it's about 620 tons in mass. So 620 tons of mass to be lifted, we have to generate 1000 tons of thrust, 500 each. So and each of them generate about something like initially 600 and then they settle down to 500 each. So it's a large thrust.
It's a very large thrust, and I think there is some overlap between the liquid engine kicks in before the solid motor.
You're right. Before something like about 20 seconds before the solid rockets burn out, the liquid stage is ignited.
And why do you do it that way? You need to usually you get the maximum thrust at the beginning because that's when you need acceleration. But of course, the troposphere causes some problems anyway, so you don't want to go to maximum thrust there. And is there a particular reason why there is an overlap between the two propulsion?
Because, see, in the solid motor as well as the liquid motor, we are getting the control by tilting the nozzle.
Right.
Okay.
It's a gimbal in America.
Yeah, gimballing the nozzle.
Yeah.
Now, when we are in the last 15 seconds of the solid rocket burning, it is tailing off. Its thrust is coming down from 500 tons to 0 tons in a different way. And if both of them come in a different way, if one at a given time, we have a differential thrust of say 100 tons, the control of that will not be sufficient. There should be augmented control. So the L110 we call it, liquid 110 tons stage, that nozzle gimballing will help additional control. It's a steady control. The other two are unsteady control
I see. Right.
because of the unsteady thrust, whereas this one is a steady control.
So it's just a bit like in aerodynamics when a pilot, an airline pilot, comes in and there's a bit of crosswind, he will land at a higher airspeed than he would otherwise. What are the plans for developing this site? You already have 2 launch facilities. Any plans to expand on that?
Here?
Here.
Yes, we have plans to expand because today we have capability to launch about 8 launches per year. 4 launches from each launch pad. We have 2 launch pads, first launch pad and second launch pad. We can launch about 8 launches. Of course, all of them put together, PSLV, GSLV, GSLV Mark III, all of them put together, we can make 8 launches. But we foresee that something like after 5 to 6 years, when the GSLV and GSLV Mark III also become operational, we may have a requirement of more than 8 launches per year. So we are taking up, we have to take up manufacture of another, creation of another launch pad facility. But before that, what we are doing is we have a second launch pad. We integrate the launch vehicle in the vehicle assembly building, shift it to the, drive it to the launch pad and launch it. So we have already got a project approved in which we can build another vehicle assembly building so that 2 vehicles we can prepare parallelly. So we can increase our launch rate because the launch vehicle assembly in the vehicle assembly building is it takes about 3 to 4 months. Whereas the launch pad, we have an occupancy of only 10 days.
I see.
So if you have more the vehicle assembly buildings, we can drive one after another to the launch pad.
And when you're interacting with Professor Satish Dhawan?
Yes. Professor Satish Dhawan, practically I worked under him till Professor Rao has taken over as chairman of ISRO. And my remembrance of Professor Satish Dhawan is something like, he's like something like a fatherly figure.
Right.
Okay?
Yes.
And when he fires us, when we don't do something proper, we feel as if my father is firing. We never felt that my boss is firing. And I mean, firing, the word, usage of the word firing in India is a different meaning than Western countries.
Yes.
There you fire means he's out of the job. Here firing means
reprimand.
Yeah, reprimand.
Yes.
Okay.
So SLV3, so you worked with Abdul Kalam as well.
Yes.
What was he like?
Yeah, it is a great experience working with Dr. Abdul Kalam. I worked 7 years under him in SLV3 program. He is a great motivator, I will say, and truly team building person. He builds teams. He puts them the targets which are much above their assessed capability, so that they will rise further. And then he drives them. One incident I remember very well was one night around 11 o'clock. We were living in the same lodge on a monthly rent basis rooms, he and me.
Right.
So I had to make an urgent call somewhere. So I went to his room because his room is the only room which had got a telephone at that time with intercity connection. So he was reading something and I asked him, sir, I want to make a call. And I was just maybe less than a year in the organization under him. He asked me, please make a phone call. And I finished the phone call in 5 minutes. Sir, thank you very much. And I was about to leave. He said, no, please sit. I want to talk to you. Then he talked to me from 11:30 to 2 o'clock in the morning. And given me work for a month. Okay. That is the type of person. And you never feel that he is giving you the work.
When did you last meet Dr.
I met him last when the Mars orbit insertion
Ah, I see.
in the September 2014 when we were in Bangalore. He came specially to meet all of us, wish all of us all the best. At that time I met him. Of course, he remembers me very well.
Of course.
Because I worked long with him.
Before the SLV-3, the ISRO worked with the French CMS and developed under license the Centaur rocket here. Were you involved in that as well?
When I joined SLV-3 beginning, there was some Centaur launch. But basically, I am an electronics engineer at that time. So I'm not connected with the design or manufacture of Centaur rockets. But one Centaur rocket was flown, one or two Centaur rockets were flown with the avionics systems as the payload. How do they perform? And very interesting was immediately after I joined, after 1.5 years, one Centaur rocket took off with 9 avionics and electronics payloads, like sequencer, which sequences various events, the commanding system, the rocket tracking aid, which we call transponder. 9 of them are flown and 6 of them failed. They did not function. And that is the time I found that the electromagnetic interference is the basic cause of all the problems. And when I approached, immediately after analysis of data, when I approached Kalam and Madhavan, saying that all these problems are because of electromagnetic interference, which was just evolving at that time. This field itself was evolving.
Right, yes.
Previously, it used to be called RFI, radio frequency interference. Of course, a lot of work is done by US and other people. But in India we didn't do. So both Dr. Kalam and Madhavan Nair, they encouraged me so much to work on that field.
Right.
Even today, Kalam remembers me as EMI EMC person. And I was personally leading this activity. We have introduced EMI design considerations, EMI test facilities, electromagnetic compatibility solutions, and so many things which made, I will claim, which made SLV-3 possible.
Right. And when you were in Paris, I was wondering what perception you had of how the Europeans saw ISRO at that time in the 1990s.
You see, when I was in Europe, it was 94 to 97 yen. At that time, we have not yet proven any big launch vehicle.
Right.
We had a number of satellites launched, but the first launch of PSLV, which failed, took off before I left in 93, before I left for Europe. And when I was in Europe, there was the first success of PSLV in the 94, as soon as maybe a few months after I reached there. So there were a lot of questions to me. In fact, I still remember BBC asked me a question. A poor country like India, why do you want to spend money on the development of the launch vehicles when there are so many launch vehicles in the world? And the answer I gave them is, when you develop Ariane launch vehicle, there were so many launch vehicles in the world. Why did you develop it? Okay? And I said, independent access to space is our aim. Number one. Number two, yes, there is poverty in India. Even today, there is a poverty in India. And poverty can be only solved by development. And our founding father, Professor Vikram Sarabhai, told us, unless we master the latest technologies and put them to the use of the society and the progress of the society and the development of the country, that is the only route to solve the problem of poverty in a permanent way.
And that's how Europe and America have done.
Yes,
So
anybody has done the same way in their own old histories.
And the amount of national GDP that's spent on the space program is very small. How much is the total income for ISRO?
No, I should say, first of all, for almost from 1965 up to something like 2000, something like 35 years, the total amount of money which we have spent for the space research in India is equivalent to one half of what US spent in say 90s per year. Per year. Per year, the budget of NASA used to be about $15 billion. And we have spent hardly $7.5 billion over 35 years. And then, after 2005, our budget increased. Today, we have reached a stage of about $1 billion per year. So, this is the budget of annual budget of ISRO today, is $1 billion per year. And very important thing, I should say it's very important thing, when all the ESA, Japan, NASA, when all these space agencies are facing either no increase or cut in the budget, in India at that time, that is what I'm talking about 2005 to 2000 to 2010, during this period, ISRO annual budget was increasing minimum 15% per year and once 30% per year. Okay, so it quite dramatically the increase was there, and that was required for these activities. After SLV3, I joined launch vehicle project called ASLV, Augmented Satellite Launch Vehicle. That was a small launch vehicle with two strap-ons, like what we have launched now.
That was the SLV3 with the strap-ons?
Yeah, with SLV3 with two strap-ons. We had two back-to-back failures, and it was terrible time. Okay, so the whole ISRO had no confidence whether we will be successful in any mission or not. We found at that time that there are large number of things in the launch vehicle technology which we have to learn, from aerodynamics, shaping the thrust curve of the motors, and the control, transition of the control from the strap-on stages to core stage, and ignition of the core stage. Lot of things to learn. Till that time, the ignition, separation, changeover of control used to be at a prefixed time, which we used to prefix based on studying various things. So that was the time when I proposed that there should be an onboard computer. We had already an onboard computer to do the closed loop guidance and the control, but we did not link it for the sequencing of the flight events. So that is the time I proposed that the computer should monitor the performance of the motors in real time and decide at what time the control should be changed over, at what time next stage has to be ignited, so that the flight will be very smooth. It was one of the turning points, I will say, in the development of launch vehicles. And it went through number of reviews, maybe about 4 years. Nobody had a confidence it will work at that time. But it was the concept which we have taken by just studying all other launch vehicles, how they do, from the available public literature, literature in the public domain. But we designed our own thing, worked perfectly well, and third launch of that ASLV was successful. And that system is being used till today for all the launch vehicles. The onboard computers, every 20 millisecond monitors the performance of the motors, performance of the acceleration which this thrust gives to the vehicle, and at what acceleration level or what thrust level a stage has to be cut off, a stage has to be, transition has to take place to the next stage, and control transition has to take place. This is one of the, for me personally, it's a highly satisfying thing. We are maybe about, at that time, on this system, hardly about 10 people worked.
10 people?
10 people worked on this system. But it's such a crucial thing. Of course, I don't say this is the only thing which made ASLV successful. There were 5 solutions which we have implemented between the second failed launch and third successful launch. But this is one of those 5 key solutions. which worked and which made our launch vehicles very robust and reliable. Today, the PSLV is very reliable and because of this.
A workhorse, as they
Yes.
say, absolutely.
Answer you, what is my perception of the European
Yeah,
work
what did
culture?
the Europeans think of
I think I should tell the European work culture is very good. You will see the people, highly very free and democratic with their colleagues as if they are friends till they enter into the office and joking, taking lunch together, taking dinner together. The moment they enter office, they will be maintaining the office discipline. And people who spend up to late night, 1 o'clock, 2 o'clock in the dinner, we will see next day 7 o'clock jumping into the car and driving to their workplaces, which is very, very difficult. The one most important thing is the work culture of Europe had developed from the industrial society. The work culture in India has developed from the agricultural society, which is a stage which Europe experienced during the Industrial Revolution.
Mm-hmm.
So, the work culture in agricultural society is sporadic.
I see.
2 months you work very hard, 3 months you wait for your whatever you planned to grow and give you the results. And then again you work another 1 month very hard and get all the things to your home. So this is very sporadic nature of work and very leisurely type of work. And if the rain is there, you don't need to work, and when after the rain is over, you have to work. It's an entirely different thing. And from that, when we have to evolve into a very systematic industrial production type of work, it takes a large amount of effort to change this culture. In fact, I will say, whether it is Professor Vikram Sarabhai or Dhawan or U.R. Rao or Dr. Kasturi Rangan, Madhavan Nair, I think this cultural transition between our agricultural background of the society to a very highly precision demanding type of work in rocketry and satellite. I think this is their biggest challenge that you are managing us.
You know, that's very enlightening. I could not have understood that without actually being here and talking to you, because it's so, as you say, it's so cultural. Thank you. When you came back from Paris, you took over at the Master Control Facility as director. So just want to understand, when rocket satellite is launched from here to GTO, what happens to them? When does the transfer of command move from Sriharikota to, I take it, Hassan? What stage does that transition take place?
Yeah, there will be an overlap. The data which is collected by tracking of the launch vehicle, in its trajectory, and estimating what will be the initial orbit, is transferred in real time through a network to the other station. So, Master Control Facility receives from Sriharikota the initial orbit. And while it is in the trajectory itself, it can see the satellite. And the moment they get that orbit, from then onwards they take over. It is very clear.
So, you told me earlier what all the activities you perform here in the integration and preparing for launch and the launch gets into the transfer orbit. Then you hand it over to Master Control Facility. What sort of things is Master Control Facility responsible for then onwards?
I will say, among all the directors' seats in ISRO, the hottest seat is the Director Master Control Facility.
Really?
Yes.
I see.
Because there are 15 satellites under control of Master Control Facility.
15.
And on every satellite, after being in GSLV, you have to do north-south station keeping, east-west station keeping, temperature control, eclipse management of the batteries, and meet any emergencies and payload requirements. This is the type of thing. Of course, when I joined MCF, this many satellites were not there. When I joined, there were hardly 4 satellites. When I left MCF, there were 10 satellites in orbit. In 7 years, we launched 9 satellites. You could think of, in 7 years, 9 satellite operations. And the most important thing is, the launch vehicle puts the satellite into GTO. And GTO to GSO transition is something like 1.6 kilometers per second velocity addition using the satellite propulsion system. Very, very demanding thing, demanding operations. I'm very fond of telling this to everybody. Before I was in MCF, because all our transponders are being used for VSAT networks, for TV, for DTH, so many things. Two big things we have faced. One is, personally, before I went to MCF, when I was watching a TV, when there is a disturbance in the TV program, what I'm seeing, I used to switch off and read some book or sleep. After I went to MCF, the moment there is a disturbance in the TV channel, what I'm observing, I used to jump into my car and go to the office to find out which satellite, which payload, which transponder is misbehaving, why it is misbehaving, which fellow is uplinking wrongly. That is one part. But more important, as an organization, something happened between, I joined 1998 MCF, but something happened in the whole world between 2000 and 2004. Up till that time, most of the places, it's analog TV. And each TV channel required one full transponder. And so at that time, if we had 10 TV channels, we used to have 10 transponders occupied. And used to be the lease rate at that time used to be $2.5 million per year. That's in Indian rupees about 12 crores per year. Within that 4 years, digital technologies have come. Digital TV has come. And such a fast way, it has become 10 to 15 channels per transponder. And because of the competition among the different communication satellite operators, the price has fallen from $2.5 million per year per transponder to $1 million per year per transponder. From 2004 till now, it's the same rate continuing, $1 million per year per transponder. So, 15 channels in one transponder, and the rate has fallen from $2.5 million to 1 million. So, something like 30 times the revenue has fallen. The demand has fallen by 30 times. Many companies wound up, and big companies like Intelsat, SCS, all these people have acquired the small companies, and we survived because of the government organization, government company. And till that time, the people used to fight in India to get a transponder. Suddenly in 2002, I started getting back the transponders. They are surrendering to me back. And how to use them. That was the time very tough for the organization, and we survived.
But right now, I thought there was a shortage of transponders in terms of the demand. The demand is
No. At that time, this was the situation. Today, yes, we have 200 transponders, and demand is more than 500. Okay, of course, we have to catch up.
Fascinating.
That is the MCF part of my life. Okay.
Okay. One other aspect, fascinating aspect of your experience, is that you were with the United Nations Committee on Peaceful Purposes of Outer Space, and United States, China, and Russia also part. And these other nations, China, US, and Russia, all demonstrated to some extent their interest, shall we say, in ASATs, these anti-satellite systems. And during the experiments that they've conducted, they generated a lot of debris. And space debris is another area of your interest. I'm just wondering, how do you see things like space debris situations now? Is it getting worse, or is it getting better over the last 10 years?
No. There are two aspects. Of course, what you said was right. The ASAT test of China in 2002, if I'm right, 2007. 2007. And the ASAT test of, it's not exactly ASAT. The USA said it is destroying one of its satellites because it has got a lot of propellant and it is almost re-entering the orbit. They shot it down. So both these things have created debris. But I think the large amount, 40% of the debris, has come from the explosions of the unused final stage, the unused propellant in the final stage of the launches and the defunct satellites. They explode because the temperature increases and the pressure increases inside and the propellant tanks explode. So ASAT of China, even though it has created about 2,000 pieces of debris, roughly, I still think that 40% of the debris were historical. And historically, if you see, the number of launches made by Russia or ex-USSR and USA are the largest number in between 1957, 58 till 1985 or 90.
Yes.
These are the basic, the old ones left in the orbit are the basic source of the generation of the debris.
Yeah.
Then, as far as ASAT tests are concerned, we are not much involved because ISRO purely works for the peaceful purposes of outer space.
It's very simple.
But any country which has got a capability to precisely launch a satellite into an orbit also has got a capability to destroy a satellite. Okay.
One most recent GSLV 3 test was very successful. In fact, it was two experiments, the GSLV 3 launch vehicle itself, and on top of that was the crew module, which wasn't occupied in this test experiment. I saw, like many people, the online launch and then the return of the module, which was in the sea, and the Indian Navy recovered it. But we didn't see any pictures of the module coming down in parachutes or indeed the splashdown. Do you know if there's any plans to release photos of that stage of the test?
No, there are two things here which I want to make very clear to you. Number one, what we have flown is not crew module. It's a crew module model.
Okay.
It is weight simulated, shape simulated, and external thermal protection system same as the final crew module, and the deceleration system with parachutes is same. But inside is not like a crew module. That's number one. Number two, yes, we have photographs of the crew module coming down with parachutes, etc., which we have, which we can show you.
Okay.
Then the third thing is the basic nature of this test was only to test the atmospheric phase of the launch vehicle.
Right.
That is the primary objective.
And the re-entry.
No, our primary objective is to test the two solid strap-on motors at L110 stage and its ascent up to 70 kilometers, the most important region in the launch vehicle's trajectory. Now, our primary objective is to test the atmospheric phase of this launch vehicle, and that was perfectly successful. We had an excellent flight. The secondary objective is because we are making it a ballistic trajectory, a re-entry opportunity is available. We had put this crew module model. And that crew module model, whatever information we get at that velocity, at 5.3 kilometers per second velocity when you are entering, real crew module will enter at almost 8 kilometers per second.
Right.
This entered at 5.3 kilometers per second. So heat flux is less. But we want to study that. So that experts are going to study. The third point is the human space program for manned missions is not yet approved by Government of India.
At the moment.
We have not got the approval for any manned mission, and we have got within our small budget of ISRO some money we have kept aside to develop certain technologies. Part of it is this the thermal protection system of the crew module model. That the story stops there as of now. Okay.
Thank you very much for clarifying that very clearly. Just last question. It's a very busy, very productive and a very successful year, 2014. We're in the beginning of January 2015, and I know things change. It's the nature of the business that you were in. But right now, what do you envisage will happen in 2015 within ISRO?
2015 we'll have 2 more launches of PSLV with IRNSS
The
satellite.
E and F.
So we have already 3 of them in orbit, 4th one and 5th one we'll be putting into orbit. That is definite. We also have a plan to launch AstroSat, which is the astronomy satellite in multiple frequency bands, which is ready. Then we are also working for the next GSLV launch with the indigenous cryo stage. So second launch of the indigenous cryo stage. So if it is successful, then we will be stabilizing in the GSLV history. Okay. So at least I see about 3 to 4 launches, and 4 to 5 launches per year is a very, very busy period as far as Satish Dhawan Space Centre is concerned, because everybody will be busy almost all through the year.
Yes.
Then of course there will be changes, and there are expected changes, anticipated changes in the management of the ISRO at the top level, which we have to wait and see.
Dr. Prasad, I could sit here and talk to you for hours. I know you have other duties as well. But for the moment, I'm very grateful for your time. Thank you very much indeed.
Thank you. It's a